Hello students, in this video we will continue with the first chapter in Science 1, that is laws of motion. So students, let's learn the distance time graph for uniform motion. Now in the previous video we had learned about the uniform motion and non-uniform motion. I hope you all remember. If an object covers equal distance in equal time interval, it is said to be moving with a uniform speed. So, for uniform motion, we require two things, that is distance and time. Here in this table, time is given in seconds and distance is given in meters. We need to plot a graph according to the given data. So, on the graph, we will plot time on the x-axis and distance on the y-axis. On the scale, we have taken x-axis 1 centimeter is equal to 10 seconds and on y-axis we have taken 1 centimeter is equal to 20 meters. First is 0, 0. So time will be 0 and distance will also be 0. So our first point comes here. Second is 10 and 15. So on time we will take 10 and from distance we will take 15 and our common point comes here. Then second is 20, 30. So we will plot 20 from time and 30 on distance. And so on we will plot all the points. And when we will join all the points together, we will get a straight line. So the distance time graph is a straight line. Now why it is straight line? Because it is moving with a uniform motion. That is, the object is covering equal distance in equal time interval. The distance and time both are with equal intervals. That is the reason the graph between distance and time is a straight line. Let's now see the distance time graph for non-uniform motion. Well, when an object covers unequal distance in equal time interval, it is said to be moving with a non-uniform speed. So, for this graph, again we require two things, that is distance and time. So, here in this data, we have time in seconds and distance in meters. We will plot a graph according to the given data. X-axis we will take time and on y-axis we will take distance. Scale here we have taken x-axis 1 centimeter is 5 seconds and y-axis 1 centimeter is equal to 10 meters. According to the given data, we will plot the graph. First is 0, 0. So, our first point will be 0, 0. Second is 5 and 7. So, on x-axis we will take 5 and on y-axis we will take 7. Next is 10, 12. So, on x-axis we will take 10 and on y-axis we will take 12. Next is 15 and 20. X-axis we will take 15, 20 on y-axis. And so on, we will plot all the other points. When we will join these points, we will see that the graph is not a straight line. So, for non-uniform motion, the graph is not a straight line. So now, what difference did you find in the distance time graph for uniform and non-uniform motion? Well, for uniform motion, it was a straight line as the car was covering equal distance in equal time intervals. And the graph for non-uniform motion was not a straight line because the car was covering unequal distance in equal time intervals. Let's now learn the velocity time graph for uniform velocity. Now, here in this graph, we have plotted time on the x-axis and velocity on the y-axis. Here, a train is moving with a velocity of 60 kilometers per hour for 5 hours. So, how did we get a straight line here? Now, as the train is moving at 60 kilometers per hour, so the train starts at 60 kilometers. First R, that is on time, will take 1, and from velocity we'll take 60 and we'll plot the first point here. Then second point, second R from here, and 60 from velocity, our second point will be here. Third point 3R and 64R and 65R and 60 and so on. So this is how we get a straight line in this graph. Now, with the help of this graph, we will have to determine the distance covered by the train between 2 and 4 hours. So now we need to determine the distance covered by the train between this time, between 2 and 4 hours. What was the distance that was covered by the train? Chalo, let's calculate the distance covered by the train. Now children, you must have remembered that in the previous video, that is I guess the first video, we had studied about velocity. So the formula for velocity was displacement upon time. Displacement is nothing but the distance. So velocity is equal to distance upon time. Now here we need to find the distance. So the distance covered will be velocity into time. Our velocity here is 60, as the train is moving at 60 kilometers at all the time. So 60 will be our velocity, and time here between 2 and 4 hours is 2. So it is 2. 60 multiplied by 2, the answer is 120 kilometers. That means the distance covered by the train between 2 and 4 hours between this time was 120 kilometers. Next, we need to find that is there a relation between the distance covered by the train between 2 and 4 hours and the area of quadrangle in the graph. So, in the graph if we'll see the area of quadrangle, that is we have to find the area of ACDB, and we need to calculate whether the distance covered by the train between 2 and 4 hours, which we have already done, was 120 kilometers, and this area are equal or not. Is there any relationship between these two things? Next, we need to also find the acceleration of the train between this time. So first, let's find the answer to the first question. Is there a relationship between the distance covered by the train between 2 and 4 hours and the area of quadrangle? So earlier we have found out the distance covered by the train was 120 kilometers, and now we will find the area of quadrangle. So the area of quadrangle ABDC will be length into breadth. Length here is 60, breadth is 2. 60 multiplied by 2, we will get 120 kilometers. So yes, distance covered is equal to the area of ABDC. That means yes, there is a relation between the distance covered by the train and the area of ABDC, which is the quadrangle here. Next, we have to find out the acceleration of the train. Now children, we have learned that the acceleration is the rate of change of velocity, and the formula for acceleration is final velocity minus initial velocity, that is v minus u upon t, that is the time taken. So here if we will see in the graph, the train had started at 60 kilometers per hour. At 1 hour it is at 60, 2 hours it is at 60, 3 hours also 60, 4 hours also 60, and so on. So our time here is 2, as we have to calculate the acceleration between this time. But our final velocity here is 60 and our initial velocity here is also 60, as the train is moving with the same speed. So final velocity minus initial velocity upon t, that is 60 minus 60 upon 2, which the answer will be 0 meters per second. 60 minus 60 is 0, 0 upon 2, the answer is 0. So here our acceleration of the train is 0 meters per second, and the distance covered and the area of quadrangle is 120 kilometers. Next is velocity time graph for uniform acceleration. Now here in this table, the changes in the velocity of a car in specific time intervals are given, and on the basis of the given information, we have plot a graph here with time on the x-axis and velocity on the y-axis. It is a uniformly acceleration, so the graph is a straight line. After you plot all the points, we get a straight line. As the velocity changes by equal intervals in equal time intervals. So we need to remember that for all uniformly accelerated motion, the graph is always a straight line. Now first, we need to find that how much velocity changes every 5 minutes. So if you will observe this graph, the velocity is changing with 8 meters per second in every 5 minutes. You will see here it is 8, 16, 24, 32, 40 and so on. So it is changing with 8 meters per second for every 5 seconds. Next is, we need to calculate the distance covered by the car between the 10th and the 20th second. So between the 10th and the 20th second, we need to find the distance here that was covered by the car. So if you will observe here, we have extended these lines to the point here. And we have got here as A, B, C, D. And to find this area, we need to first add A, D, C, E and A, E, B. That is rectangle and a triangle. As you can find here, one rectangle and one triangle is present. If we will add this both thing together, then we can find the answer for A, D, C, B. So let's find out the answer. Now, area of quadrangle of ABCD will be equal to AECD plus ABE. Now, we know the formula for area of rectangle, that is length into breadth, and area of a triangle is half into base into height. So first we will put the values for area of rectangle. So let's look here, area of rectangle, our length is 16 and our breadth here is 10. You can find here 10 to 20 it is 10 and 0 to 16 it is 16. So we get L as 16 and breadth as 10. Next, from this triangle we need to find the base and the height. So your base is 10 and height is 16. Let's put the value in the formula. 16 multiplied by 10 plus half multiplied by base, that is 10 into 16, which is the height. And when we will calculate this, our answer will be 240 meters per second. So the distance covered by the car between the 10th and the 20th second, between this 20th second is 240 meters. So the car had covered 240 meters, the distance between the 10 seconds. Hope you all understood the concept. Thank you for listening. Take care. Bye-bye.